Good afternoon and welcome to this webinar. I'm Cyriel, Communication Officer at ERA, the European Union Agency for Railways, organizing this webinar. How can rail companies concretely embed safety in their organization, especially in maintenance activities? ERA's Executive Director, Joseph Doppelbauer, and my colleagues Nathalie Duquesne and Jean-Marie Deschamps will explain why maintenance of vehicles is an important topic. They will discuss with representatives from the sector the tangible benefits and practical implementation of these projects. I wish you all a very fruitful webinar. For those who cannot attend, I remind that this webinar is recorded and will be available on our website and YouTube channel later on. I now give the floor to you, Nathalie, to facilitate the discussion. Thanks.
Okay, thank you very much, Cyriel. I'm project officer at the agency since 2007, and one of my main tasks is to follow the implementation of the regulation 779 about ECM certification. And today I'm very happy because we have invited 3 ECM managers. We have one from CFL Cargo, one from CP, Portugal, and one from SNCF Freight. Maybe let me first to give you some details about the organization of this webinar. During this webinar, you can ask questions via the chat that you can have at the top right of your screen. But if you want, you can also tag questions from the other attendees. It could be useful because we have 2 moderators who will check your question and after a filter to find the perhaps 5 more important questions. So don't hesitate to do that. Now, I would like to give the floor to our Executive Director, Mr. Doppelbauer, who will introduce the webinar. Mr. Doppelbauer, the floor is yours.
Many thanks, Nathalie, and good afternoon to all participants. Ladies and gentlemen, welcome to our webinar on maintenance. To maintain or not maintain, of course, you all immediately think of the famous quote from Shakespeare's Hamlet, to be or not to be, that is the question. To maintain or not to maintain, for me, this is not a question. Maintenance is an essential activity that is necessary to guarantee the safe operation of the railway system. When a railway vehicle or an infrastructure is used, it will be subject to wear and tear and may get damaged and therefore will not remain fully conform to its design operating state. The goal, and this is the official definition, the goal of maintenance is to restore the vehicle in its design operating state. Entities in charge of maintenance, ECMs, therefore play an important role for safety in the European railway system. All railway vehicles, both for passengers and freight cars, must now have a designated ECM. ECMs ensure that the vehicles for which they are in charge are in a safe state of running by means of an effective system of maintenance. Therefore, a vehicle can only have one ECM assigned in the National Vehicle Register at any given time. On the 16th of June 2019, the European Commission introduced the new Commission Implementing Regulation 2019-779 to replace the former Regulation 445 from 2011. The new ECM regulation extends the scope of the Railway Safety Directive to all vehicles registered in the EVR. It also introduces requirements for manufacturers and ECMs to manage safety critical components. Today, I'm very pleased that we have the representatives of ECMs from Portugal, France and Luxembourg. which will explain to you the importance of the maintenance development function. ECMs are the best actors to update and to modify the maintenance development based on monitoring and, of course, a proper risk analysis. As all railway actors, also ECMs need to exchange and communicate with other railway stakeholders, as safety is our common goal. Now, I will give back the floor to Natalie to remind us in more detail of the main goals of our seminar today. Natalie, please.
Thank you, Mr. Doppelbauer, for this brilliant introduction. You say everything. So now with Jean-Marie, before giving the floor to our speaker, I would like to show you some slides and first to explain what does maintenance mean and to give the floor to Jean-Marie. Jean-Marie is a bit the daddy of the ECM regulation and with a lot of experience, not only at the agency but also in maintenance workshop, will explain what does maintenance mean. Jean-Marie?
Thank you, Nathalie. Good afternoon to everyone. I will speak about the maintenance and to fix the IDs. Mr. Doppelbauer has spoken about the design operating state. What is this state? This state covers all the conditions that are necessary for the vehicle to be operated on a safe way to ensure safety, but also to meet the requirements addressed by the customers in terms of cost, in terms of type and frequency of operations, in terms of speed, and so on. So the use of the vehicle is clearly linked to this design operating state. But as for any technical system, the railway vehicles assist to a degradation of performance all along the use. Degradation of performance that can at certain moment impair the safety, but also the other requirements of the customers. And that's why we have the maintenance, and the maintenance is so important because the maintenance is the operation, it's the set of operations that aims to restore the vehicle in its design operating state or in a state just close to the design operating states while ensuring at least the safety, but also all the other requirements of the user.
Now, you know what does maintenance mean. But which type of vehicles? So when you speak about railway vehicle, we speak about wagons, of course, wagons that you can find definition in the TSI wagons, but we speak also about other types of vehicle, like locomotive, passenger cars, twin set, multiple unit, EMU or DMU, but also on-track machine. All these vehicles need to be maintained by only one ECM. That it is important to have in mind that in the National Vehicle Register, these vehicles must to be registered with the name of one ECM. Now we speak a lot about ECM, but what it is an ECM? ECM, as you can see on this picture, it's an entity. Nothing very new about what we have in the past years about entity in charge of maintenance. What we have stated in the safety directive, but also in the regulation, is to formalize a bit the different activity of an ECM. We can find in one ECM the function 2, dedicated to the maintenance development, an important function that we can discuss especially today to build, to upgrade this maintenance plan. When we have this maintenance plan, we have also the fact that we have to call the vehicle to come in a maintenance workshop to be maintained, to be repaired. That it will be the role of the ECM function 3 about fleet management. And in the maintenance workshop, ECM function 4, we receive the maintenance order and we can realize the maintenance works. So what it is also very important is with these three functions, it is crucial to manage correctly the function and that it will be done by the ECM function 1, the maintenance management. Now, because today is more oriented about maintenance development, I give the floor to Jean-Marie to have more details about this maintenance development function.
Thank you, Nathalie. Now, regarding the maintenance management system, it's covered by the four functions as said by Nathalie before. We will focus a bit more on the maintenance development, but on this slide you can see the link, the interface between the four management level. The maintenance delivery needs to get maintenance order, needs to get request to maintain the vehicle. And of course, they need to have also the vehicles. This is provided by the fleet maintenance management. But to define the task to be given to the maintenance delivery level, there is a strong need to have a specific set of processes within the ECM that is covered by the maintenance development. The output of the maintenance development is, it has been said, the maintenance file that contains on one side technical detailed documentation necessary for the maintenance and documentations kept up to date, but also what we call the maintenance plan, meaning a set of activities, of technical activities with frequencies defined or with milestones defined. But to get this maintenance file and to get this maintenance file up to date, there is a need of many processes based on risk assessment, based on risk management, that have as input the information coming from operation, especially the damages, the problems met during operations by the railway undertakings or the IMs or by the keepers, or if we imagine for freight wagons by the loaders. Those informations are necessary input for the maintenance development. But also there are, we can say, long-term informations on operations that are the performance targets that are required by the customers of the ECM. Of course, it's difficult for an ECM to start to work its maintenance development without any initial technical documentation, mainly coming from the manufacturer of the vehicle. There are also other elements that must be taken into account. What we call under the technological survey is in fact grouping different aspects like the obsolescence of spare parts, particularly critical in railway as the long life cycle of vehicles, but also the evolutions in maintenance methods. For instance, going from preventive to conditional to predictive maintenance, there are new methods put in place that requires a transformation at the level of the maintenance development. We have also the evolution of the legislation and the possibility to impose some requirements. And finally, informations of safety critical components that will be developed in a future webinar on which the agency now is actively working. Now I think that we can go, as we have fixed a bit the what means the maintenance development, to the experience of the ECM represented in this webinar.
Yes. Thank you, Jean-Marie. Time is running, and everybody knows that we can speak and speak a long time about this important point. Now, I'm sure that you are very interested to hear the sector, and I would like first to give the floor to Geoffrey Tresantini, the ECM manager for CFL Cargo in Luxembourg. Geoffrey, please, could you briefly present you and describe your activities as ECM manager?
So I work as ECM manager for CFL Cargo since 2012. We are managing a fleet of wagon of 2,500 vehicles and a few locomotives too, but it's not directly under my responsibility. So I will keep my message on the wagon maintenance. It's the question was to maintain or not to maintain, and I think it was really interesting to answer directly by yes, we need to maintain it, but we need to define how and what are the best way to answer the most common expectation that we can have with the maintenance issue. So I retry. So just to explain what are the main activities of CFL Cargo, we are railway undertaking. We have all the roles that we can find in railway. So we are railway undertaking, keeper, maintenance workshops, ECM, and we work on several countries. Western Europe, Northern Europe, and also in Germany, and now we are starting some activities in Switzerland and so on. So I will go deeper in the question of how we are organized, because I think it's quite interesting to explain that we have two companies that are directly involved in wagon maintenance and especially ECM. We have CFL Cargo, that is the main company, and we have also CFL Technics, which are the workshops, all the workshops we have, and we have split the responsibilities for function 1, function 2, and function 3 of ECM on CFL Cargo, and function 4 on the workshops. It's quite common as an organization. We have we want to just to say that we have a lot of other certification like ISO and so on. But as explained by Jean-Marie, you need process to do the job quite well. So all the kind of certification and management system helps you to do the job on the best way, I would say. First, I think when you are in charge of function 2, you have to consider that sometimes you have to make some changes in the maintenance plan, especially because I would say all the environment of railways are moving. You have new kind of vehicles, you have new kind of activities, you have new routes that you have to follow. And due to this evolution, sometimes you have to rethink the way you are taken in account specific aspects like the use of wagons and the conditions and so on, and to redefine your maintenance plan to make it really
I think we lost you, Geoffrey. We cannot hear you and your camera looks frozen. So maybe there is a slight network issue, which is not a problem. Can you join again? Are you back? No, don't think so. Maybe Natalie, I will give you back the floor and maybe we can go to the next speaker then in that situation. And then if Geoffrey comes back, he will be able to end his presentation, right?
Okay, no problem. We have to wait, Geoffrey, to explain how he managed the maintenance plan, but I think to avoid waste of time, I think we can give the floor to João. João is the ECM manager for CP in Portugal. João, the floor is yours to explain how you manage your maintenance of Pendolino in Portugal. Now we are online. Please, João, go ahead, and we will come back after. Thank you.
Okay, so thank you for your invitation to be here. I'm João Januário from the CP Comboios de Portugal, the Portuguese Railways, and today I'm going to talk a bit about a journey through our reliability-centered maintenance in the Portuguese Pendolino fleet. So the agenda for today, I'm going to talk about the RCM project, from the sketch to the key on the CPA maintenance, the operational context for implementation, RCM analysis and approval, RCM field implementation, achievements, and the online RCM, the new step forward. So the operational context for the implementation. The project started in 2003 after expiring the manufacturer warranty period. So it was developed in close cooperation between CP, the train owner and operator, and MF, the ECM. And in 2020, they both merged. It served as a testbed for an integrated new way of thinking, organizing, executing, and managing all rolling stock activities of the CP fleet. So our fleet consists on 10 intercity type 6-car EMUs with hydraulic active tilting technology. They started operation in 1999. The length of each train is 160 meters and they reach 220 kilometers per hour. They were consortium built, have distributed traction, a really high equipment density, and they were and still are non-conventional due to their complexity. So just for passenger comfort, we have many systems. Of course, the active tilting system with active lateral suspension, vacuum toilets, bar, steward call system, electrical curtains, individual audio modules, Wi-Fi, individual power outlets. So a really high equipment density along the train. So as of 2003, we had the traditional maintenance approach with standard manufacturer maintenance plans that consisted on light activity maintenances and periodic system overhauls. But we should remember that train manufacturers are just integrators of systems from different sources. So what was the traditional maintenance approach? A compilation of generic sub-supplier plans. They don't take account the train configuration. They are independent of the operating context and weather. They are unaware of failure consequences. They are costly and mostly ineffective. As of 2003, from the train operator point of view, our fleet had low availability, poor reliability, constant service disruptions, and suppressions. Among all, we had our fleet. It was a flagship of CP, but had a poor commercial performance. As of 2003, what our experience said. That this traditional maintenance approach was not adapted to our operational context because we had complex trains, a small and inflexible fleet with high service performance demands. And our workshop dealt mostly with radium failure modes, with infant mortality, intrusive maintenance problems, as we can see here on these graphs. So next step, RCM analysis and approval. Take a new whole system approach and seeking consequent mitigation rather than failure avoidance. The challenge of this project was, of course, to increase availability, create an environment of safety and reliability, increase fleet annual mileage, reduce life cycle costs, update MF maintenance business for newer and more complex trains, and to improve competitiveness of CP as an operator and MF as a maintenance provider. So the project preparation, everyone at the workshop at the workshop floor took a 3-day course on the RCM methodology. The RCM facilitators had a special training. We defined the systems to be studied. We studied 12 systems as here on the right, and we scheduled the analysis. So the analysis took about 15 months to complete. From the analysis itself, we selected the review groups, collected relevant documentation, manuals, statistical data, technical data, defined the system boundaries and operating context, did a FME analysis, failure modes and defects analysis with the application of the RCM decision diagram, definition of appropriate maintenance tasks, and at the end, preparation of the final analysis report. By the end of the project, I had a final audit with a commitment from the directors board. So as a result of this project, 70% of the maintenance tasks were new or changed, a new maintenance cycle was sketched, a new quality plan was sketched, and safety on work procedures were improved. With this 70% of the maintenance tasks that were new or changed, 49% were failure modes that didn't require maintenance, just corrective maintenance when the failure occurs. And the 47% of failure modes that do require maintenance are hidden failure finding tasks, 23%, on condition tasks, 56%, scheduled overhauls, 12%, scheduled discards, 6%, and 2% a combination of some of them. The most important, 4% of all the failure modes required redesign. So the RCM field implementation, the most important step on this project. It all took some changes on the maintenance and work procedures. So with the introduction of LRUs on the maintenance management, preparation of new maintenance documentation, work orders, implementation of new maintenance plans approved by the regulator, introduction of wait-and-see approach and life exploration programs, introduction of new policies for spare parts repairing and overhauling, designing of a new RCM maintenance information system in-house, the PGS 4000, as we can see here on the right, and the implementation of a feedback improving process. So this maintenance information system that was developed in-house is LRU structured, fed with reliable data from the workshop, provides on-time fleet status overview, and helps managing the PF curve and CBM tasks. So as I said, the feedback is really important in this process because it helps us validate our maintenance by practice and update the system with new failure consequences. And the achievements of this project. The reliability increased, so the occurrences decreased by 50%. And what is an occurrence? Is a delay of more than 10 minutes caused by train faults. So this occurrence decreased by 50%. Our availability increased by 20%, and in the life cycle costs, we experimented a system lifespan extension. From our experience, it's more effective to seek consequence mitigation than to seek failure avoidance. The corrective maintenance is the most effective action for about half of the failure modes. 80% of all maintenance tasks are condition-based or hidden failure finding tasks, and we successfully eliminated train set strip downs until the midlife refurbishment after about 20 years of service. So this not only improves of course, the maintenance, but the operation with increased reliability, decrease in downtime, and increase in availability, reduce costs with the optimized maintenance, reduced probability of failures with safety and environmental consequences, and brought us a positive culture shift where we increased the culture of reliability, proactive thinking, cooperation, and knowledge of the system. It provided a new robust maintenance design justification file where maintenance decisions are justified, recorded, traceable, and auditable, preserving valuable corporate knowledge. Also optimize the list of spare parts, and this project drives subsequent updates based on experience. So some numbers. We can see here from the start of the project in 2003 that the annual kilometers of the fleet had gone up to about 3 million kilometers per year. We just have a 10 train fleet. And in 2017, we started the midlife intervention, but and of course, one train had to be stopped on the workshop at that time. But the kilometers remained the same with the less one train to operate. In terms of availability, we can see here an increase from 2003 with 7 trains available for service to 9 trains available from service in 2006. Don't forget, our fleet at that time was just a 10 train fleet. At 2017, we started the midlife intervention, and these years, for example, 2018, we had 80.88 train availability, with just 9 trains to operate. Unfortunately, in 2020, we had 2 major accidents, and this 77.5 train availability is for 8 train fleet, because 2 of the trains were stopped at the workshop for repairings. In terms of reliability, the occurrences had decreased to 10 occurrences per million kilometer to about 4 or 5. And it became more or less steady at the time. At the start of the midlife intervention, we had one train stopped. We had a shorter time frame to do some corrective maintenance, and of course the occurrences gone up for a bit. But after the end of the midlife intervention, the numbers were more or less the same as before. So in terms of regarding life cycle costs, we experimented the lifespan extension. We can see the example of the traction motors. They were scheduled to be overhauled every 1.8 million kilometers, but with the life exploration program, we increased their lifespan to 5.5 million kilometers without an overhaul and of course without incidents. But this RCM project is not only to increase the lifespan of the components. We have also the example of the cardan shafts. They were due to be overhauled every 1.2 million kilometers, but we thought it was not enough, and we ballast them every 600,000 kilometers and discard them at 3.6 million kilometers. So the next step forward, the online RCM. It was defined in 2009 as a key project. It was driven by the RCM maintenance strategy and helps feeding data to the RCM process and project. It was a redesign on the train diagnostic system and enables online hidden failure finding tasks and online condition-based tasks without human intervention. And of course, also enables faster remote troubleshooting when you have a problem and the train is stopped on tracks. And thank you for your attention.
Thank you very much, João. It was very interesting. Thank you for your transparency, because sometimes it's difficult to have these type of figures. And now I would like to give the floor again to Geoffrey. He will explain in some words how he managed the change in the maintenance plan, but also to give some information on the financial feedback. Geoffrey, if it is okay, the floor is yours.
Okay, thank you to give me back the floor. I will share back the presentation. So, as you can, as I explained before, we always try to manage evolution of maintenance plan in order to keep the objective of safety, reliability, availability, and efficiency. But when you engage some changes, you can have some position about some aspects that lead to some relevant maintenance activity, and also because of the history, the return of experience you have in the past, and so on, you can also define some irrelevant maintenance activities. And all the work, all the difficulties is to be able to identify each of them in order to avoid to spend some time and money in some irrelevant activities. So okay, so as I explained before, we are focused on the goals that are behind the changes. And because we are in charge of function 2, we have to, I would say, use our main core activities to pass from the goals to the achievement. And by the way, we have to be able to list and to define clearly what and how we want to follow the process to get a streamlined maintenance plan in order to avoid, I would say, some easy faults that are due to the fact that we always repeat the same use of the same habits in maintenance. And because most of the maintenance plan that we have for wagons are based on rule-based process, we are trying to pass from rule-based to risk-based. That is the point. So first, we have to ask some questions. So here there is some example. What are the steps to follow? What do we need to define? And all the time you are in the assessment phase, I would say. The most important thing is to take in account return of experience, information sharing, and all the monitoring you have on your fleet, on the condition of use you have, and to be really close to the field. The common expectation, as I say, are in most of the time to avoid to do overhaul or replacement of parts when there is still a running potential, to increase the relevancy of action you do during the maintenance steps, in order to really increase safety, not just because it's plain, but because it's needed. And not because it's a rule, but because there is a risk behind. That's the point. And at the end, improve the quality or the resistance, the potential, the running potential of parts that are often damaged and under wearing limits. You know, for our business, we have a lot of wagons that are used in steel business. So you have some stanchions, you have some woods. Shells on the wagons, and you have, because due to the kind of goods you are transporting, you have some damages on, and you need to find some solution to increase this life cycle. So Natalie asked me what were the most the main difficulties to handle when you have to make some maintenance plan changes. And I think there are a few of these difficulties on this slide. So first, get the relevant data about real condition of use, because in our case it's quite easy because we have a fully integrated company with railway undertaking, workshops, and so on. But sometimes it's quite difficult to get the feedback from the customer or from the loader and so on. Get the real data about wearing situation and damages, because you know, with GCU and so on, you have some part of information about what are the damage, but sometimes it's not so detailed, and you can easily take some conclusion that are not so relevant at the end. A really important point is to establish the pain-gain balance of the change, because when you have to handle a change, you need to be aware about the fact that it will, at the beginning, it will cost some resources, it will cost some time, some efforts. So are you ready to do that? And do you have from your stakeholders the I would say the sponsoring that you need to do in that? You need also to accept to step back if there is some unexpected effect due to the change. So the kind of recovery plan has to be set before engaging real changes with big effects or with some hazardous potential behaviors on vehicles. You need to be aware about the fact that you have to take people from the, I would say, the engineering department to the workshop out of their comfort zone, because you will do some change. So it means you cannot stay in your habits and so on. And at the end, you have to rely on a risk-based maintenance instead of a rule-based maintenance. And that's the point, because, you know, rule-based maintenance is quite easy to mind. You just have to do what is written. And when you use risk-based maintenance, you have to always mind it and remind it. Okay, so I will go deeply with this small process chart. And I say, before handling change that can lead to all the expectation that we point before, you have to think some things before. So first, assess the risk of changes. After, plan how to come back to old maintenance plan if there is some severe issues or unexpected effect. Then define how to overview and manage vehicle maintenance planning, because sometimes it's not so easy when you have thousands and thousands of vehicles. It can be a plan that takes some years and years to be able to cover all the fleet. Find out to identify the vehicles that are concerned by the new maintenance plan, because sometimes you have to rely on several workshops in several countries. So it's not so easy to say to all the people what they have to do and when. And then you need to clearly set your plan on the paper, I would say, and set the action to do in order to keep it under control. Who, when, why, and all the points that you need, like budget also, because we all it's about money, and to be clearly able to expose what are the current situation you have and what is the expected situation you want. Because if you are not able at the beginning to define it clearly, it means you will miss some really important steps for sure. So because money is an interesting point of the maintenance plan change, and sometimes it's the first, I would say, input of the way you can follow the changes you want to apply. I would show you some figures. So for our experience, we have the last 5 years, but especially the last 3 years, we have deployed rule-based, risk-based maintenance instead of the former rule-based maintenance plan that we use. And we can see that we were able to keep the availability at the same level than in the past. We can keep the same level for the GCU reform rate, so for the damages that we have on vehicles and the wearing situation that we can encounter. But we have reduced the expenses for maintenance by 40%. So in our case, it's several millions of euros each year that are saved due to the new way to thinking maintenance, and due to the fact that we are based on risk now, and we are not doing maintenance because it's written in a book that are 40 years old, but we are looking to do what is really interesting in terms of safety, availability, reliability, and efficiency. And that's the end for me. So thank you to listen me, and sorry for the problem with the network.
Okay, thank you a lot, Geoffrey, for this very clear explanation. Now I would like to give the floor to Maud. Maud, I would like to ask you if you can, in your presentation, explain the different links between the different functions. We had explanation about the function 2, but I trust you that you will explain that it is also very important to share the information with the other function. Maud, the floor is yours.
Thank you and good afternoon to everyone. I'm Maud Allègre. I'm the responsible of ECM management for Fret SNCF since 2020. And Fret SNCF is a certified ECM for all its own vehicles since July 2020. Just to present briefly our ECM. So we are ECM for our fleet that is made of 30 type of vehicles, split between electrical traction units, thermal traction units, and some passenger coaches that are mainly used for military transportation. So to explain a little bit of what we are doing during as a ECM, we are ECM 1, so we manage the maintenance, and we subcontract our function 2 to SNCF. And we manage directly the fleet management and also our workshop. So that's how we are organized in Fret SNCF. And I will also to answer you, Nathalie, about how we manage all this function. My presentation will be mostly on the interaction, on the link between ECM development and the other function. Mainly the realized functions such as function 3 and function 4. Just to be clear of where we are in the life cycle maintenance of our fleet, we mostly work on the maintenance file updating, and we are of all of our fleet, we are in the life cycle of our vehicle. We don't have new vehicles, so we don't work in the initial maintenance file. We have some authorization type of vehicle, but it's a little part. And we manage also the end life management, but this part will be more in the keeper's hands than in the ECM for us. So I will explain you the right-hand side diagram that show you that all the four functions are linked by output and input information, and they are giving and working all together. So if one of them is defected, we will have some issue with the ECM management. So mainly what we are looking for, it's all the information that's going out and going in the different function, and especially from the maintenance development. So I will go through this two interaction. First of all, between the function of development to the fit maintenance function, we have strong interaction, especially about maintenance plan that are given from the development to the fleet management to give them enough information to program and to plan all the maintenance and the constraint to the operation system. So the first output from the development, it would be the update maintenance file with plan maintenance view, and level of and type of maintenance that we need to do. Also, in the maintenance file, we also have a logistic management part that will give to the fleet management work instructions, skills, equipment, tools, spare parts, and materials that are very important to organize the maintenance and to planify it. Also, development function will give to the fleet management the operation, all the emergency measure or all emergency events that that they will know, such as operation incidents, some anomalies detection that have been found in other workshop, or mainly regulatory recommendation such as SIT. And by the way, but that's the main information we need. It's all the evolution of the maintenance plan that we can have, and to be sure that we can realize the evolution that the development part will give it to fleet management, all evolution information that's in the plan. In return, fleet management will give back to development also information that will help us to improve the maintenance plan, such as the articulation between the maintenance and the operation constraints, just to be sure that we are in line with the maintenance aspect and the operation aspect. All the feedback we have regarding operation and all the feedback we've got regarding performance about workshop and operating activities. And also the fleet management can be informed earlier of all emergency information on safety related issue, and will give this information back to the development system. I will finish with this the second interaction between function that I want to explain you. It's mostly between development and workshop. So the development will give also information directly to the workshop, such as logistic management that will help the workshop to put in place all the logistic that they need to deliver the maintenance. So it will be work instruction, skills, maintenance tools, spare part, materials that the workshop will need to do the maintenance. It will be also the emergency information, such as they give to the fleet management, and by the way, the evolution of maintenance plan. In return, the workshop need to give back some information to be to have some information of how the maintenance is realized, and also all the improvements the maintenance plan can have to facilitate the work of the workshop. So it will be maintenance delivery, traceability of the executed work, also all the configuration applied on the vehicles, all communication of failures, anomalies that have been noticed during the maintenance work execution. But also they can make some proposal. The workshop can make some proposal to improve the maintenance, the maintenance files. It can be deviation, so just to find another way to do the maintenance, and it can be also evolution on the work instruction with new tools, different equipment, or maybe another way to do it. So I think these interactions are very important in the ECM management and the ECM function, because you can see that all of them are linked all together, and they need to work all together, and to make the information going through the different function. Thank you for your listening.
Many thanks, Maud, and many thanks to our three speakers. We still have a few minutes before the end of this webinar to reply to some of the questions that you, dear attendees, kindly asked in the chat, and thank you for doing that. So I will first ask a first question to Geoffrey, and I kindly ask you for a short answer because we really are running out of time. What part of the freight wagon is the most critical that needs to be maintained perfectly at all stages of a wagon life? Please, Geoffrey.
So I think there is a most critical parts are interfaces between wagons and track, and due to this point, I think wheel sets, buffers, draw gears, all the things that makes you can have some big troubles with the ability of the wagons to run well and safe are the most critical parts for me. But it depends if you are using tank wagon, and there is other point that you have to take in account. There is not it's not a rule, I would say.
Many thanks, Geoffrey. My next question is for Joao. Joao, how do you improve your braking system through CBM, rather traditional or with digital means? Joao, please.
So I was actually answering to that. So of course, all systems have different specifications, but it's not something that we can say to all the systems. But I think the FMEA analysis of a certain brake system will have for sure, or not, an answer for that. If the system has some tasks that can be maintained through CBM, it will be a result of the FMEA analysis. But the FMEA analysis can also have the output that you can't apply the CBM to that system. So.
Many thanks. And last but not least, now a last question for you, Maud. So this is a very technical question. How do you define the CBM features on air production systems? Are they included in the components, air generation unit, or do you analyze the TCMS data to predict maintenance on the train? Maud.
I'm not sure I understand all the question, and I'm sorry because I cannot see them. So it's about. Can you tell it again, please?
So the question, oh, sorry, and now you can hear me, sorry. The question was, how do you define the CBM features on air production systems? Maybe the first part of the question is already enough.
I'm sorry, I don't think I can answer this question.
No worries.
Right now.
No worries. I will now give the floor to Nathalie Duquesne.
Okay.
Yes. Sorry, Maud, the question was not easy, but I'm sure that after reflection and to give this question in your team, you can provide an answer, and because we have the contact of everybody, people, the staff, the person who asks this question will receive answer from you and from your team. Don't worry with that. It is a very specific technical question, and
yes.
With that, if I may, Cyrielle, I would like to say that we have also a question about safety critical components that we will organize in November, the 22nd of November, the same time of meeting, but especially focused on safety critical component. And we are very happy to say also, because the agency has a role to make communication and a real dissemination about technical matters, that we are ongoing to build some trainings, especially on maintenance activity via e-trainings, that it will be possible to follow before the end of the year or perhaps at the beginning of next year, because we have seen with this webinar, with this number of attendees, that it was very important for all the sector to have more information about the maintenance activity. Now I give the floor back to Cyrielle. Thank you.
A lot, Nathalie, and even if we couldn't see you, we could hear you. We are now reaching the end of this webinar. First, let me thank warmly all of our speakers and the colleagues involved in the preparation of this event. I want to thank them not only for their contribution, but also for their enthusiasm and their support. Thank you for your attendance and participation, dear attendees. Before you go, we would be very happy to receive your feedback on this webinar via the link provided on the webinar webpage on the ERA website, or via the QR code that you're seeing right now on the screen and that you can flash with your smartphone. We look forward to meeting you again at our upcoming webinar in a month on the 16th of June about human and organizational factors, from busting myths to practical tools. In the meantime, if you would like to stay updated on our activities, please sign into our database by selecting the button Login on our website page. I thank you very much for participating. We wish you a very pleasant afternoon. Take care. Thanks.